Okay, hi everyone. For those of you who don't know me, I'm not actually part of SPREE, I'm Ian McGill. Ziv can't be here today, and I was sort of asked to make the introduction, really just because Rob, Anna and I and others Anna Bruce and I and others have had some discussions with Rob, and it's a shared area of interest around this work around community PV and community energy more generally. Obviously there's people in law, a couple of them here today who are working in that space. There's people in Faculty of Science, Francisca, and the former Institute for Environmental Studies, Emily and others in SPREE have projects. Anna has projects in this for standalone systems, so it's a general area of interest. So Rob's going to be speaking on regulatory issues, which look to be pretty critical for those of you who may yourselves be involved in trying to get community PV projects up and discovering all of the hurdles on the way. And Rob's particularly going to draw on lessons from telecommunications, which, if you've had a chance to look at his bio, Rob's done many things. I don't think it says in your bio, but you started as an electronics engineer.
Yes,
so,
comms engineer.
Comms engineer. He spent time as a regulator. He spent time as a lawyer.
Working for a law firm as a regulatory specialist.
Mediator.
Yeah.
International finance. And has fairly recently really joined Australian School of Business. So please join me in welcoming Rob.
Thanks very much. And thanks for that very kind introduction. So what I'd like to do today is just to run through essentially the normal sorts of issues that are associated with talks like this. What motivated me to get to have an interest in this issue. Some of the access issues that I see in community PV. And then I'm going to try and draw on some experience in the telecommunications environment. And the basis for doing that is to argue that many of the issues of network access that flow from community PV look like new and big challenges, and incumbents will always paint them as new, untested, untried challenges with horrible unforeseen consequences that are so horrible that they can't even foresee them. And I'm going to argue that actually almost all of these issues have been dealt with in other regulatory environments, and in particular in telecommunications. So I'm going to look at telco, other access models, and then try and put to bed some of the incumbent pleas that you will no doubt hear over the next few years and draw some conclusions. However, what I would really like is to get some feedback. So my thinking comes from quite a specific and narrow area of regulation of networked industries, but primarily in an environment of telecommunications rather than in electricity. And perhaps I hope that what the feedback from you will do is actually lead to the development of a paper which is based on the issues that I bring up today. And I hope that the two other outcomes don't come to pass. One is that you worry about seeing me as an example of what happens to an engineer fallen among lawyers. Or perhaps even worse, which is I become an exemplar of why RF engineers should be left nowhere near the grid. Okay, so what was my motivation? I'm going to go through some of the bits on the slide. But actually, my motivation was primarily listening to Declan, who's here, Bronwyn Morgan, and other people in the law faculty while I was doing postdoc work in law, who were looking at structures, business structures, that would facilitate community PV. And actually, not just community PV, but community generation in general. Now, I'm one of these people that says, oh, there's A, B, C, D. Oh, we go A to D. So I've made the assumption from almost immediately that Declan and people like him would be able to resolve the structural issues. So what happens next? What happens when you have community PV business structures, whether they use existing legal structures or new ones? How do you actually get to have a microgrid? Do you have to build complete new infrastructure? And in particular, why can't you use infrastructure that has been provided by others? And the question, of course, becomes a lot more relevant when you have devices like the Powerwall and other storage products, that suddenly PV on a community basis isn't a question of trying to share a resource that's only available during daylight hours. It's sharing a resource that could mean that connectivity to the grid is minimal, or potentially connectivity to the electricity company supplied grid doesn't happen at all. And in that context, what I was interested in is having a look at the access regime for electricity systems. There isn't really an access regime for electricity systems. There are mechanisms for access to interconnectors. There's a mechanism for retail contestability, but all of the things that I would expect to see based on experience in telecommunications, in ports, in airports, in pipelines, they're sort of not there. And what's more, the issues that the electricity companies, particularly the gentailers, are talking about are issues which are based on a set of assumptions that don't seem to be the right ones. So we're going to argue about how much the feed-in tariff should be. We're going to argue about whether you need to have a particular tariff for electricity that you consume if you're also going to take advantage of a feed-in tariff, which sort of seemed to me to be narrowing down on an issue which was nothing to do with the likely outcomes that would come from a community PV system. One of the key things that comes from that is that contestability is based on services. So it's like saying, oh, well, we're going to have an access regime to railways, but you've got to use our rolling stock. It's a bit like saying, yes, we'll give you access to gates at an airport, but you've got to use our planes. And in a telecommunications environment, say, well, we have access to infrastructure, actually multiple mechanisms for access to infrastructure, as well as access to services. So it just seemed to me to be odd and jarring compared to access regimes in other sectors. And one of the big motivations, especially having chatted with Declan, was to look at, where do I live? I live in Glebe. I live in a house where there are lots of other terraces quite close by, where we have, because it's close to Sydney Uni, a number of academics who have work at home for some of the time. We have a number of people who work in television, and they tend to work during the night. You have a different mix of people, and you also have a number of roofs, most of which have got a pretty good north-facing aspect. So that potentially having PV on each of the premises could be shared more efficiently than just having each house go to try and get the best deal that they can for their household alone. So, what's the real motivation? The electricity bill. But there are other things along the way. So, I'm going to try and explain what I'm thinking of in terms of setting up a microgrid. And I'm going to suggest that you've got broadly two separate forms of microgrid. You can do one which is single phase microgrid, or you can go for a three-phase solution, and probably you want some hybrid of single phase and three-phase. You could, in a community PV approach, say, well, we're going to have a battery per household, or you could end up with storage on a central basis. That has different sets of issues, whether you go for a central or a distributed storage approach. And broadly, to help me think about this, I used an approach which was described by Sun Zhao, Guerrero and Zhang, which is a sort of hybrid of a three-phase microgrid and a single-phase microgrid with connectivity back to the utility, so that you've got interconnection with existing distribution networks. Now, I'm not going to dwell on this diagram. It'll be the slides as well as the video will be available. But essentially, it just helped me to think about the issues as I was going through. So you've got some particular issues in terms of load balancing, all those normal things of how do you deal with a three-phase system. But you've also got perhaps a more complicating approach. If you've got an environment where a three-phase supply is being delivered to multiple premises, and I thought about it because I live in a street in terms of a street, but it's exactly the same issue to think about if you have three-phase on a vertical riser in a block of units, or multiple dwelling units. The challenges are quite different if the microgrid is closed and universal to the micro area than they are if the microgrid is open and some people aren't on the microgrid. Especially if it turns out that every third house on one side of the street decides that they don't want to be part of a community PV system, because you start to get real issues with load balancing back to the utility, and issues with thinking about, well, how do I set up an environment where those people who are not part of that microgrid can choose to buy their electricity directly from the utility, even though I might actually have some infrastructure that their electricity is supplied through in order to make the microgrid work. So all of these solutions and all of these issues require reticulation, certainly of AC, that's easy, and potentially of DC, and that's less easy, and they require access to the distribution infrastructure, the electricity infrastructure. And they require something else, and are quite likely to require something else, and that's interconnection downstream of the substation. So I don't want, in thinking about these regulatory issues, to assume my microgrid is going to be at substation level, because it might be, but it might not be. So having interconnection downstream of the substation is an issue to deal with. So that's where I was coming from in thinking about community PV issues. And ultimately, we've got a regulatory environment at the moment which is based on a set of perfectly valid assumptions that were certainly perfectly valid 20 years ago about generation, about transmission, distribution, and an assumption of centralised generation. That is, there's an assumption that in telco terms there's a core network. It's also an assumption in the regulatory settings that the connectivity is on a per premises basis and often on a per phase per premises basis. And when I started thinking about this, it seems to me that this sounds like the telecommunications network which was operated by the Postmaster General's Department and Telecom Australia. The only network that you could actually trust would be the network that the government owned. It had a core, it had a transmission network, it had a distribution network. So the interconnection of exchanges becomes the core network. The distribution network is between the exchange and the premises. And certainly 30 years ago, you would have to acquire your telephone from Telecom Australia if you were going to plug it into the network. Because who knew if you put some telephone that was made probably by the same company, had the same connector on and plugged it into the telecom network, terrible things might happen. Network integrity might be threatened, the safety of people working on the network might be threatened, and you might actually think about these issues in electricity terms just as well. So what I was thinking about is sort of how do you change these settings? How do you move from an environment that's based on a big set of assumptions, and a set of assumptions which is quite similar to the set of assumptions that's used in other sectors, and get to something a bit different that would facilitate community PV. So I'm going to do a brief intro to the telco environment. In the telecommunications environment, there are bottlenecks, and there are elements which are really, really expensive to duplicate. So an example of a bottleneck is a mobile phone. I can phone Ian. I can use this device. I could use Skype out. I could probably use a telephone, except that it's only connected to the IT system, this phone, to call you. Which network are you on now, Ian? Go on, admit it.
Optus.
You're on the Optus network. If I'm dialing you, calling you on your Optus number, only the Optus network can terminate the call to you. Because your phone's connected to the Optus network, it's not concurrently connected to the Telstra network and the Vodafone network. It doesn't matter if you're an AMASIM customer and you're Optus and you're using an underlying Optus network. If your phone is connected to the Optus network, there is a bottleneck. I have to use the Optus network to connect to you. In the fixed line telecommunications network, the bottleneck's a lot easier to see. It's a piece of copper twisted pair that runs between the exchange building and your house. Except for those of you under 25 who've already cut the cord and you don't have fixed line networks at home anyway. But ultimately you've got these issues. So what you have is some form of monopoly characteristic, and traditionally there's been an approach which says, well, telephony, water, gas, electricity, these are natural monopolies because the distribution network is too expensive to duplicate. And so historically, these types of network have been government owned and operated because it's a natural monopoly, you may as well have the government running it. But in many of these sectors, it's changed. And the change has been to say, well, actually, we don't need for this natural monopoly to be owned by the government, provided that we can have a mechanism by which you can get to workable competition in terms of access to the network. So for a few of you who can remember back to 1994, when Optus first started offering fixed line services, Optus built its own core network and bought access to the Telstra access network. So if you used Optus at the time, if you wanted to make a long distance call, you would dial 1 for Optus. Blank faces, there really is history coming through here. And you would be able to use the Optus core network and get a slightly cheaper price and much, much better service. That was the argument that Optus made. Did you have to build new infrastructure? No. Is this like retail contestability? It sort of is, but it actually, because ultimately what Telstra was doing there was selling a service rather than infrastructure access. But over time, and I'll run through the issues in this, telecommunications access has moved from services-based access to infrastructure-based access in the same way that rail access, particularly in the mining environment, port access, airside gate access. Only the airside of Sydney Airport is regulated, as you'll know if you've ever parked there. But you have all these things that are designed to get to a form of workable competition. So what are you doing? Well, you allow potential competitors to get access to the bottlenecks. How do you make sure that that works properly? Well, you give the incumbent, the owner of the bottleneck, a normal rate of return for that access. That is, you allow them to recover the weighted average cost of capital. So it's a real profit from an accounting perspective, it's no profit from an economic perspective, but it's enough to make sure that the costs of operations and maintenance of the infrastructure is recovered. It's enough to ensure the shareholders are happy or moderately happy, but it's not going to give you a supernormal return. So the pricing mechanisms, and we understand this similarly in the electricity environment, is designed to give a normal rate of return at the weighted average cost of capital. Just like in electricity, where every reset, consultants, including people like me in the past, have made a fortune out of opining on what the weighted average cost of capital should be, those arguments were had in the telco space as well. It's just that those arguments were had between 1997 and about 2002, and those issues are primarily parked since then. So how do you get access? Well, essentially the ACCC declares the relevant service. It puts the service on a list of services which it regards as having bottleneck characteristics and for which others can acquire. Australia's one of the first countries to do this, and it came up with this "we'll produce a list" approach. Malaysia also has a list of services. In Europe, you have it the other way round, where the incumbent gives a reference interconnection offer. Essentially, it says all comers can acquire the service on these price and non-price terms, and essentially the regulator looks at that offer, first time says it's outrageous and not good enough, come back and change the prices and change the non-price terms, and then it's published and others get access using it. So interconnection in telco is pretty similar to interconnection in electricity. It's the linking of telecommunications units in order to allow carriage of traffic, electricity carriage of electricity, across those units. And so in the first bits when I was mentioning with Optus, the service that they acquired was a service between a fixed line phone through a local switch. A local switch is a device that sits in your local telephone exchange building, through a transit switch. Transit switch is a switch which has the characteristic that it has no telephones connected to it, to a point of interconnection. In Australia, there were 66 points of interconnection. So if you buy an originating service, which is the top one, and buy a terminating service, which is the bottom one, you can put your own connectivity in between and you can sell telephone calls. And the first approach in most countries to liberalisation of telecommunications was to have long distance bypass and international bypass using these services. So a service-based approach. That doesn't work for broadband access, or rather it does work, and the incumbent will quite happily say, we will produce a white label service which allows you to supply broadband to your customers. But ultimately, if you do that, the service levels are determined by the incumbent and not by the new entrant, by the competitor. Instead, there's an approach which says, well, perhaps you could get access to the infrastructure. If the infrastructure is the bottleneck, you could get access and provide services. So in the Australian distribution network, you have a local switch connected to a main distribution frame, which is basically a whole series of connectors. Then there is a dedicated copper pair that goes from the MDF to a premises. In fact, typically there are 2 pairs per premises, so that if something goes wrong, Telstra can swap the pair over while it works out what's wrong and then fix that over time. And the reason for that is that you have a customer service guarantee that says your phone will be back on in 4 days, otherwise Telstra pays $17. In between the frame and the premises, you've got those things called pillars, and you may have noticed if you've walked down the street you'll see a pillar. They don't always have a handle like the one that I've got up there. On the other hand, they are the mechanism by which the last few hundred metres is connected back to the cable that runs from the exchange building. In an environment where the major thing that you're going to do with telephone lines is to deliver broadband services instead of delivering telephone services, what you do is to use the telephone line to carry data using the bit of the line that isn't being used for voice. So essentially you can set up a broadband service between a DSL modem that people have sitting at home, and so DSL is digital subscriber line, and a DSL access multiplexer that sits in an exchange building. And if you have a broadband service at home that isn't Telstra's Big Pond, then if you're getting a service from TPG, which includes iiNet and Internode, or from Optus, they're using their own electronics in the exchange building, acquiring the bare piece of copper from Telstra, and then you probably have to go and buy your own modem to go on the end, or they will sell you a modem. So we've got access to infrastructure, not just the pits or the pipes or the poles, but to the actual copper itself. And regimes for that access have been well established. Now there's an argument to say, oh well, there's a problem with that because in an electricity environment we don't have a dedicated piece of copper that runs between a substation and a premises, where our distribution is at 3-phase, we're dropping off for each home. Well, that looks pretty much like hybrid fibre coax, where you have fibre that goes to a node, a coaxial, initially used for the delivery of TV services, coaxial hard line that runs along the street and literally taps, which tap into the coax that's going along the street with a drop down to a home, so that you've got a common resource that's being used by multiple homes. In the NBN, that'll be 50 homes sharing one common access line from a node. Telstra currently runs 500 homes past that are sharing, because cable take-up's relatively low. You can still get broadband services which are delivered quite quickly. Passive optical networks, fibre to the premises, fibre to the home, is similar. You've got one common outgoing wavelength at 2.4 gigabits per second, a second wavelength coming back at 1.2 gigabits per second, and a passive splitter. Up to 32 premises are served from the split. In practice, you have 20 real premises served from the split and capacity to grow up to the 32. And this is how fibre to the premises or fibre to the home is delivered. A big fat pipe being shared across multiple splitters, multiple fibre lines through a passive splitter. And the reason for bringing this up is that, well, actually in electricity, we're now getting to say, well, Telco has addressed a number of these issues in terms of a comparable analogue to a three-phase supply. So the access regime provides access to services. That's at OSI layer 2, where you know the physical endpoints, and to infrastructure. And the same regulatory regime, a regime that first came into effect in 1997 and which has been modified over the last 20 years since to take on the types of lessons that would come from a PV regulatory environment, is used for both. And essentially the drivers of it are terms that you're familiar with in the electricity sector, long-term interest of end users. And that's defined in terms of competition, because it's telco any-to-any connectivity, but importantly, encouraging the economically efficient use of and investment in infrastructure. We have other access models which could also be used. So Part 3A of the Competition and Consumer Act essentially allows the ACCC to declare access to nationally vital infrastructure. Primarily, it's mine railways that have been used, but could also be used for ports, airports, or pipelines. Essentially, in this case, similar to telco, if there is a market failure, that is, if access to the services is not provided, then the ACCC can step in and declare access. It provides a service description, and access is available to an access seeker. It's a bit of a horrible process because it takes a bit more than a year to do, but potentially it's a mechanism without any legislative change that could be used if you could start to argue that there is a national interest in having access to distribution networks, electricity distribution networks at a local level. Where it doesn't work is if it's a single community PV system that's seeking that access. But potentially if it's a group of communities that have a common interest in access, you could get to the national significance threshold that's required. So, what do incumbents argue? They argue, and they always have argued, that there are issues with network safety. There are issues with network integrity. And there are issues in both cases. But you can actually solve those issues by ensuring that there are relevant standards associated with the mechanisms for interconnection. In Australia, those standards and codes are published by Communications Australia, which is an industry group of stakeholders. The incumbent will normally argue that, well, because of the issues, we should be providing you access at a service level. So we'll provide services, we'll allow retail contestability, but we actually control the network and control how the distribution is done. That's different from the infrastructure access that you get in the other access regimes that I've mentioned. I think what's really important is that these arguments are really well rehearsed. They're gone through. Acting for, not Optus, but another telco, mobile telco, mobile number portability, the sky was going to fall in. It was going to cost $300 or $400 million per carrier to implement it. There's a real risk that everybody would migrate at the same time, and you get a horrible outcome for consumers. And, well, I can keep on going, and I was very fortunate. My objective was to delay mobile number portability for 2 years, and I managed to delay it for 2 years, 6 months. It was great. These are the types of arguments that are run. But the sky doesn't fall in. Most incumbents actually can survive quite significant changes in regulatory regimes without there being a problem. So, I would argue that designing an access regime which would facilitate microgrid deployment isn't novel. That actually the issues that have been dealt with in ports, in telecommunications, in rail, in airports, actually mean that we have the learnings to be able to build a regulatory regime without reinventing the wheel. Dealing with most incumbents' objections has also been dealt with in the past. So it's going to be reasonably readily apparent what lines of argument are likely to be run by the incumbent and how to deal with them. It used to be really great fun in telco in the late 90s, where you could listen to an incumbent's argument in one country. I was doing work for Optus at the time, and object that this was outrageous, and then working in Hong Kong for the incumbent, run that same argument again and find that the regulator didn't actually get the same pushback. Those learnings have been gone through. So what those well-rehearsed incumbent arguments are well understood. I think there are some specific challenges that arise from community PV. In particular, issues of load balancing are particularly apparent. But they're not impossible technical issues to resolve. And so what I would argue is that what we need is an approach that says we should have, to facilitate the deployment of community PV, access to the infrastructure of the existing electricity companies on terms which will not disadvantage them. They'll still be able to make their normal rate of return on those, and that having that access regime of itself will facilitate the deployment of community PV. But what I'd really like to know is where I'm wrong so I can fix it up and then write this thing up. Thank you.
We've got time for questions, comments, suggestions, pushback.
Hi.
Hi. I'm interested about what's the pricing model that's used in telecommunications, and I'm thinking about how in electricity that the prices that people pay for using the network doesn't necessarily reflect the cost of providing the network to that customer. So how you might resolve that issue in this kind of model.
Although traditionally the approach has been to take what's called a total service long run incremental cost, and that is the cost that would be incurred by an efficient operator to provide that service. Now, by using the term efficient operator, you avoid issues of prudential whether investment was prudential or not. And you say, well, actually, we've got, for example, a copper line between an exchange and a premises. We know that historically it's had costs which were associated with the copper itself. We can give an estimate and a deflator or inflator as to the civil costs of the pipe in which the copper runs. We know that the O&M costs, the operations and maintenance costs of copper, we can actually use real costs. We can then argue about whether the incumbent is being efficient in those real costs, but actually that tends to be in the noise. So you build up a cost on that basis. What you find then is, well, that's not really going to be very fair because we can't do it on a premises by premises basis. But what you do in telco, and in most countries, certainly in this country, you say, well, we'll divide the country into sort of 4 bands. People who live in city areas are either in band 1 or 2. If you live right in the city where line lengths are short, then that's band 1. If you live in the rest of most of the cities, that's band 2. We'll take an average line length and cost it on that average line length. Regional Australia and remote Australia, bands 3 and 4, you have essentially longer lines, but a slightly different cost structure. So in the metro areas, typically lines are underground. In the more regional areas, lines are typically aerial, and you have slightly different costs. Higher in O&M, lower civil cost to begin with. So this original approach was total service long run incremental cost. The current approach is a building block model, but essentially it says, well, we know what's prudent because it's what an efficient operator will do, and the regulators around the world actually quite happily publish what their prices are. So we can do a second test by doing a benchmark against comparable countries. Now the regulator, I've been through this as the regulator and the operators can argue about what's comparable and what's not comparable, but ultimately you can actually at least test, am I in the right ballpark? And you can end up with answers, yes, you might need to do some changes which reflect purchasing power parity, for example, in terms of civil engineering costs. The labour costs might be higher or lower in different countries. But you can actually start to get to a benchmarking approach, a building block approach, a long-run incremental approach, and triangulate between those to get to an answer. Hi.
Thanks for that. I'm just trying to picture what it would look like, what in terms of the electricity case. So as what we're talking about, you'd have maybe 10 houses that are close by, and they're paying the owner of the poles and wires and everything some fee to say, yes, we'd like to use these wires,
Yep.
but we're going to generate electricity and kind of send it to each other and
Yes.
kind of add it up all together and work it all out amongst ourselves. But we kind of have a fixed fee and we don't have to be connected to AGL for our retail or whatever. Is that the picture?
Yes, but also that's the basic picture is we want to access the wires to reticulate our own generated electricity. But what we might also want to do is ask the utility to interconnect with us through a 3-phase interconnector for both when we need power from the grid and potentially when we've got excess energy to sell back. Now, as a practical matter, I think it's much more likely that the energy provider is going to say, we don't want your electricity if you're using our poles and wires to reticulate between yourselves. So we may not have a feed-in tariff there. But if you've got enough community PV that actually has excess energy to sell, it starts to change the whole, well, as you'd be aware, the whole economics of the extent to which you need baseload power stations. So you would want the interconnector, firstly, to be supplied by the community PV group itself, and secondly, that there's an obligation on the utility to interconnect to that interconnector.
So just to clarify, is there an actual extra electricity wiring, if you like, on top of what's already there that would need to be put together? It's because it sounds like, because you could do it virtually, I guess. You could not change anything and just have, I don't know, meters or something like that, and just kind of count how much, this person has put into the system and out. Or you could have a completely separate system which joins at one point, and then everyone else uses it, this kind of duplicated wiring system between these 20 houses.
Okay, and what I'm trying to do is avoid duplicating the wiring system. So if the 20 houses form a community group, PV group, that they should be able to use those wires to be able to reticulate electricity amongst them. It should be entirely at that community PV organisation's discretion as to whether they're using central storage or distributed storage. That in effect, the community PV organisation, I nearly said company, the organisation interconnects to the utility and buys electricity at the community level, and then if it's buying and reticulating, how it charges the community members should be entirely up to that community group. Does that answer your question? Or? Hi.
Hi Rob, I'm glad we finally got you to come and give a talk. So I was trying to understand what you're suggesting from a rail network perspective.
Yep.
Okay, so because that's nice and physical, and I can see trains
Yep.
going left and right. So say there's a infrastructure which is a rail network,
Yep.
and you have a number of rail transport companies having access to that rail network.
Yes.
These whole issues of intermittency and load and service. So those rail transport companies have to commit or agree to some sort of schedule where they can put trains into the network and take trains out of the network. So is that that would also need to happen in terms of an electricity network. So you would have to, any service provider on that network would have to commit to only putting in so much electricity at given times. Like you've got time to put electricity in,
Yep.
and you've got time to take it out. So that means at a user or a service level, there has to be that control over feeding into the grid. So this balance issue.
Yes.
So that would happen at the service provider. Is that your understanding? So for electricity?
Can I draw the rail?
I quite like the rail because I can see.
Yes. Okay. So imagine a single track rail going between a port and two mines. You do need the scheduling in order to allow mine B to shift its product to the port and avoid sort of holding up mine A or being saying I want access when you don't actually want access. In the PV in community PV environment, ultimately what you want to be able to do is acquire electricity from the utility perhaps at some points in time. So what you might end up having to do is to pay a fee which reflects some cost to that retailer or that distribution provider for getting access to the generated power at that time. Now, given that we've got an MCO, we could actually get the spot costs of doing that, and potentially a sensibly dimensioned community PV system could actually say, no, you're going to have to turn your air conditioners off because we can't actually afford for people to acquire energy at the price that's available at that particular time. But what you would do is say to the service provider, you have an obligation to provide electricity when it's required, but the price that you pay shouldn't be at to force you to make a loss in providing it.
But it is a bit more complicated, because if you're a rail transport company, you can have enough trains and you can know that if you schedule to put a train on the line at a certain time, you can do that. But if you've got PV power, you can't go.
No, but in the types of railway where there's an access regime, you can't quite do that either, because you're digging stuff out of the ground, and if your stockpile of iron ore is sitting in a big pile and you schedule for your train to leave at midday, and then a mechanical excavator that's putting the iron ore onto the train breaks down, you might well reschedule it to 12:30. You still need to liaise with the other mine or the access provider in order to be able to have access. So it does have some comparability. So there's generally not an access regime in terms of passenger trains. There is in goods trains, so you have those similarities.
Okay. Well, look, it's 1 o'clock. No one's trying to barge in here, but perhaps some of you do need to run off and so on. And perhaps if you can hang a bit after this.
Sure.
Lots to think about there. I must say, Rob, I look at Sydney Airport or the railways in the UK and don't see a very positive model of regulation. Looks like an absolute disaster. I'm really interested, obviously, in the telecom space. We don't really see community. We see community Wi-Fi.
Yes.
And that's interesting. In my old house, our neighbour used to use our Wi-Fi and pay us in bottles of wine. So rather than set up his own connection. But lots more to think about in this space. Okay, please join me in thanking Rob.
Thanks.